All right, we're going to take a look today at P8, polynomial lengths of 2D shapes. And you'll notice there on the screen, I have a number of formulas for different shapes, such as rectangle, circle, triangle, trapezoid, parallelogram, and a regular polygon shape. We're going to going through this lesson, we're going to look at some examples of how can we find the area and the perimeter of different shapes, but using polynomial lengths instead of having regular number lengths. So we're going to use letters in there. And then how do we use multiplying, adding, dividing, and subtracting to determine what the values are, again, in polynomial terms. So just be aware that you can use this. One thing about perimeter is that perimeter is just adding up all the sides in a shape. So if it's a rectangle, we're just adding all four sides. Now there is a perimeter formula, but you don't necessarily have to use that specifically. You just add up all the sides of that shape. So let's take a look at a couple of examples. We're going to jump into the first one here. The first one is a rectangle. This rectangle has sides of x and 2x. What it really means is that one side has a certain length and then the other one is twice that length or 2 times that length. So if you want to pause here, try to find the perimeter and the area, and then when you start back up, then we'll jump into the answers and what they look like. All right, so let's take a look at how we come up with the perimeter to start. We're going to start with perimeter. Remember that we are adding up all the sides. Now you might look at this and be like, well, there's 2 sides missing. Yeah, well, yes, there is. But we should be able to recognize that if we see one side is x, its opposite side is also x, and then 2x on top means that the bottom is also going to be 2x. So let's add all these sides together. Well, it's going to look like this: x plus 2x plus x plus 2x. Now, if you want to use the formula for perimeter of a rectangle, you can gladly do that as well. It's just going to look a little bit different because we're going to be multiplying instead of just adding. One thing you'll notice about this here is we have a bunch of like terms. They all have an x. So we have 1, 2, 1, and 2. And when we add that all together, we're going to get a total of 6x or 6 x's. So this rectangle, the size of it all depends on what x is. So it's variable. But we know that once we know what x is, our perimeter is going to be 6 times that number. Secondly, let's take a look at the area. Now, area for a rectangle, hopefully you understand this formula, length times width. So we're going to multiply 2 of the sides together, so x and 2x together. And it's going to look kind of like this. Now, when we multiply polynomials, remember that we are multiplying our numbers together. So 1 and 2 get multiplied together. And then we also multiply our variables together. So x times x gets multiplied together. And we should get an answer of 2x squared. So again, the area of this rectangle is all going to depend on the value of x. What length are we putting in there for the up and down piece of this rectangle? All right, example number 2. Let's use a triangle. Go for it. Try to find the value of our perimeter and area, and then unpause once you are ready. Okay, welcome back. We're going to start off with the perimeter of this triangle, and the perimeter of the triangle, again, is adding all the sides together. Now, we only have 3 sides, so we're just going to add those 3 sides together. The 2x is not a side, that's a height. So we're going to add the 3 sides, x plus 4, x plus 7, and x plus 5 together, and it's going to look something like this. So when we put them all together, we have our 3 sides, we're going to add them together. Now remember that we can combine our like terms, and so we're going to combine all the x's together, and we're going to combine all of the numbers together. There are 3 x's all being combined, so that's going to be 3x, and then we have a 4 plus a 7 plus a 5, which means our constant is going to look like 16. So the perimeter of this shape is 3 times x plus 16, and that would, again, we just have to figure out what our value of x is so that we know what the value of our perimeter is going to be. Secondly, we're going to look at area. Now, our area formula for a triangle is base times height divided by 2. The base and height of the triangle are based on the two lengths that meet at a 90-degree angle, and the height is going to reach to the apex. So it's from the apex or the peak of our triangle down to our base, okay, or to one of the sides, meeting at a 90-degree angle. And so our length, our base and our height are x plus 5 and 2x. And so we're going to plug those into our equation here, x plus 5 being the base, 2x being the height, and then we're going to divide our answer by 2. Now you might be a little nervous, well, what if we're going to get a decimal? The examples I'm using are no decimals, but if we were to, we could get a fraction. We'd leave it as a fraction or fraction number or fraction coefficient to make sure it's as accurate as possible. Now, when we multiply this together, we're going to come up with this here. We're going to get 2x squared, which is x times 2x, and we're going to get 10x, which is 5 times 2x, divided by 2. We need to divide both of these terms by 2. So 2x squared divided by 2 is just x squared, and 10x divided by 2 would be 5x. And so the area is x squared plus 5x. Now what you'll notice a lot for the area is we're going to either have like an x squared, if that tends to be our letter we're using, or we might have two letters that are combined together, so like x times y or something like that. All right, next example that we're going to look at is a circle. Now a circle has a bit of a special case to it, and you might be wondering, well, how are we going to do pi with all this? And that's the special case. I'd like you to try. Go for it. Try to figure out what the area and perimeter are of this shape, and then unpause, and we'll go back through the example. All right, welcome back. Let's look firstly at perimeter. Our formula for perimeter of a circle is 2 times pi times radius, or if you want to think of it as pi times diameter, but that's just multiplying the radius by 2. So in this case, we have the radius of our circle being 3x, and so I'm going to use the radius formula for perimeter. We're going to plug that in and plug that in for the radius, and now you'll notice that we have 2 times 3, which is 6, and we're going to take pi as a variable. We're going to just leave it in there as a variable, even though we know what the value is. We'll leave it as a variable, and so our answer in this case, nice and clean answer, is 6 times x times pi, and that's just what we're going to leave it as. We don't need to simplify it at all. We'll leave it exactly like that. If you really wanted to multiply the 6 by pi, you're going to get something like 18 point something, and then you got 18 point something times x. But we can just leave it as 6 times pi times x, or 6 times x times pi. Now area, we're going to do something very similar in that way as well. Our formula is pi r squared, which means we need the radius squared. And this is where it's helpful to have the radius. If we have the diameter, we got to divide it by 2. And so we have pi times 3x squared. Now 3x squared, 3 squared is 9, x squared is x squared. So therefore we're going to get 9x squared pi, or 9 times x squared times pi. So this is 9 times x times x times pi. You can gladly just leave it like that. You don't need to try to solve for what is 9 times pi. You just don't need it. It's unnecessary. It would be somewhere in the 28 range. But it's going to be a decimal, so just leave it like this. It's just a little bit simpler that way. All right, our last example that we're going to look at here is a polygon. Now this polygon specifically is a octagon. That's an 8-sided shape. And you'll notice that it has a base length of x and an apothem of y. So this is just the numbers that or the values that we're given, and we are going to plug those into our formula. So first step, I'm going to do perimeter. Okay, again, if you want to pause it and then come back to it, you gladly can. But we're going to jump right into perimeter. So there are 8 sides to this shape, the octagon, and each side is x. So what we're going to do for perimeter is just multiply 8 times x, and we're done. So the final answer just looks like this. It's going to be 8x is going to be our answer for perimeter. And then for area, our formula that we use is this one right here, BAN divided by 2, where B is the base length, which is going to be an x, A is the apothem, which is going to be a y, and N is going to be the number of sides. In this specific case, we have an 8, and then we're going to divide that all by 2. So when we plug it in, it looks kind of like this. We can rearrange it a little bit. I'll put the number up front, and we're going to do it in alphabetical order. So it's 8 times x times y divided by 2. Now 8 we can divide by 2, it makes it a 4, and so our area is 4xy. When we're doing this, we do not need to solve for what is the x and y. That we could be given later, but this is just helping us simplify things to figure out what our values are, and we're doing it with polynomials.